Hello and what's up, everyone? We're back for another lesson, and today we're talking about equations of a circle. Now, you're probably looking at the screen going, those are triangles. Am I confused? No, we're starting out with triangles because we're going to need, what we're going to do here, our Pythagorean theorem in order to help us figure out the equation of a circle. So let's get started by doing that. So remember, our Pythagorean theorem is used to find a missing side in a right triangle. And that's the situation we have for both of these right triangles here, right? Now, some of you may remember, and as soon as I start saying it, you all probably pop in your head, our Pythagorean theorem is a squared plus b squared equals c squared, right? Where a and b are the legs of the triangle, so this vertical here and the horizontal here, those are the legs, and then C is the hypotenuse, or the part that our little box here points to, right? So it points across, our hypotenuse is the longest side right there. So all we have to do right now is plug in these values, right? So A, we're going to leave blank because this is our missing spot, right? So we're going to leave it as a squared plus B, which is going to be my other leg of this triangle, 48. So we'll have 48 squared equals C, which is going to be my hypotenuse, so 50 squared, right? And once again, we're going to have to plug this into a calculator, as I always plug on this on these videos. Desmos, Desmos, Desmos. The scientific calculator is the best, right? So when we square 48, we're going to get a squared plus 2,304 equals 2,500. And what we have to do is now solve for a. So we're going to subtract 2,304 from both sides. And that's going to give me a squared. Whoops, that's a2. A squared equals, let me do my, God, I'm not organized right now. I apologize, everybody. And when we subtract 2,500 minus 2,304, we get 196. So 196. Now we just have to take the square root of both sides, square root. And when we take the square root of 196, we get an answer of 14. So that missing side there is 14. There we go. And we use our Pythagorean theorem to do so. Once again, we could do the same thing here. Now this one's going to look a little different. Why? Because we have a squared plus b squared, which are the legs of this triangle, equals c squared. Now c squared is that missing side once again. So we have to plug in our legs. A is going to be 7 squared plus b, which is 24 squared, equals c squared. Now notice, this time it's going to be a little bit easier because our c is all by itself, so we're not going to have to subtract anything from one side to the other. So 7 squared is going to give me 49 plus 24 squared. I got to go to my calculator for this one. Shout out Desmos once again. So 24 squared gives me 576. We get 576 equals c squared. Got to add our 49 plus 576. And that's going to give me 625. Oops, 625 equals c squared. Take the square root on both sides. And what do we get? Well, we do square root 625. And we get our answer is 25. So our missing hypotenuse in this triangle, aka C, is 25. And there we go. We used our Pythagorean theorem. We warmed up a little bit. This should be a little bit of a review for everybody. So now let's jump into our lesson. So our name of our lesson is x squared plus y squared equals the radius squared, which is kind of our Pythagorean theorem if we think about it, right? And we're going to connect those two things. So it says derive the equation for a circle. That's what we're doing here. We're coming up with the equation of a circle, but we're gonna discover it together here, right? So let's get started. Our learning goals for today is to use the Pythagorean theorem to derive the equation of a circle given the center and the radius, distinguish between the equation of a circle written in general form and the equation of a circle written in standard form, and last but not least, complete the square to determine the center and the radius of the circle. So let's get to it because we've got a lot on our plate today. So first off, it says find the value of the two legs of the right triangle, then use those values to find the hypotenuse. Now, if we notice, this triangle is inside of a circle, and our hypotenuse here is our radius of that circle. So we're trying to find the radius once we find the value of these legs. So first we need to find the values of these legs. For our first leg, it's a horizontal leg. So we at 0, 0, and then we go to 3, 0. So what's the difference between these two? It's 3. And it's easy because it's perfectly horizontal. So we could just use our coordinates to find out the length. Our next one, notice our 3 stays the same because this is perfectly vertical. So we're not moving left or right here. Notice that's why the 3's are the same. But we go from 0 in our y coordinate to 4 in our y coordinate, which means we're moving up 4 units. So right here, boom, we have 4. So once again, we're going to do what we did in our warm-up here. We're going to use our Pythagorean theorem. A squared plus b squared equals c squared. Remember, a and b are the legs, which is 3 and 4. So we could plug in 3 squared plus 4 squared equals c squared. But instead of having c here, I'm going to swap it out because it says r. So we're going to put r squared. So now what can we do? We square it. We get 9 plus 16 equals r squared. Add 9 to 16, it's going to give me 25 r squared. And last but not least, we take the square root to get rid of that square with my r. And we get 5 equals r. Whoops, that's not an r. R. There we go. So the radius or the hypotenuse here is 5. This is a 3, 4, 5 triangle. Nice, perfect triangle for us. So we use those horizontal and vertical values to find the radius of this circle. So in this one, what do we notice? Well, the center of the circle isn't at 0, 0 here, right? Now, everything's all switched up. And we don't have a coordinate for this point right here. But we could use the information we know to find this coordinate and then find the length of these because this is still a horizontal line and this is still a vertical line. So let's first find this coordinate. How can we find the 2 points, my x and my y? Well, the x is going to be the same as the one up here because notice we don't move left or right on this line. So the x values have to be the same. So this is going to be at 5, comma, and then my y value will be the same as my coordinate here, 2, 1. Because we're on a horizontal line, so we're not moving up and down, which means our y stays the same. So the value 1 here is going to be the same value here. So now, between these 2 points, what's different? My 2 and my 5, right? That's our horizontal change, right? It goes from 2 to 5. What's the difference there? Once again, it's 3. And then here, we go from 1 all the way up to 6. Right? So what's the change here? That is 5, right? So now we need to once again plug it in to find the radius using our Pythagorean theorem. A squared plus b squared equals c squared. And once again, we're given the 2 legs of this triangle. So we'll get 3 squared plus 5 squared equals, we're going to once again put in r squared. 3 squared is 9 plus 5 squared is 25 equals r squared. 9 plus 25 will give me 34 equals r squared. Take the square root of both sides, and this time we're actually going to need to use our calculator. We do the square root of 34, and it's going to give me about 5.83. So our radius here is not beautiful, right? It's not perfect. It's going to give me about 5.83. And that's where we're going to round it off. And there we go. We found our radius of this triangle. But look, we're still able to do it given 2 points, our center and the point on a circle. Those are the 2 points we're given here. And we're still able to find this radius using this right triangle idea. So that goes into our equation of a circle. Because basically, all we're doing is finding the Pythagorean theorem, or using the Pythagorean theorem, and that is our equation of a circle. So let's read this slide here. It says circle centered at HK. Those are going to be the letters that we use for the center of the circle. You could write the equation of any circle if you know its radius and the coordinates for the center. Suppose a circle has a radius of r with the center hk. Let x and y be a point on the circle. The distance between x and y and hk is r. So the distance formula, the square root of x minus h squared plus y minus k squared equals r. That is our equation for the circle. So square both sides to find the standard equation of a circle, right? So let's see what this looks like, and let's kind of get an idea here of what's going on, right? So we have an example up top. It says write the standard equation of a circle where the center is at 0, -9, and the radius is 4.2. So right here is our super notes, right? This is the equation of a circle where we could plug things in. Remember, HK is the center, right? These are these are the letters we use to say, hey, these are the center of a circle. So H is 0 and K is -9. So notice they substitute everything out. And then right here we have 4.2 is my R, aka the radius. So what do they do here? What they do is they plug in 0 for H. So we have X minus 0. And then for K, they plug in -9. So we have Y minus a -9. And finally, for R, they plug in our radius, which is 4.2. And then they simplify. Since we have X minus 0, that doesn't mean anything, right? We could just have X. So we get X squared. Plus Y plus 9. Where did they get this plus from? Well, it's because we have a negative and a negative right above it, right? So you combine those negatives, it's going to give you a plus. So this one we're going to leave, though, as Y plus 9 quantity, which is because it's in the parentheses. So quantity squared, and that's how we leave it. And last but not least, what did they do on the right side of our equal sign here? All they did was square 4.2, which gives me 17.64. So let's try this ourselves. Let's start out by writing the equation of the circle. So we're going to write X minus H squared plus Y minus K squared equals R squared. And let's label everything that we're given. It says our center is at 0, -4. So let's label that H, K. And my radius is 1.5. That's going to be my R. So all we have to do is substitute things in. So let's see it. We get X minus 0. Oh, just like we had above. Plus Y minus a -4. Oh, just like we had above. Equals 1.5 squared. So now that we just did this substitution step, that middle step right here, and it looks similar. So we can use these same ideas to simplify. X minus 0, that means nothing. When you're taking away nothing from something, it doesn't do anything, right? So that's just going to leave us with X squared. Plus Y minus a negative. Minus a negative really means plus. So we could rewrite this as Y plus 4 squared. Equals, and we just have to do 1.5 squared. Once again, I'm going back to my Desmos calculator. And when we square 1.5, we get 2.25. And there is our answer. This is the equation of a circle whose center is at 0, -4 with a radius of 1.5. Awesome. Now, let's try it again. But now this time, it says our center is at the origin, right? Which means it's at 0, 0. That's what the origin means, right? This isn't a little face, right? Almost looks like an owl's eyes. That's not what that is. That's 0, 0, which is my H and my K in my equation. And then it says R is 8. So once again, let's just rewrite our equation. Our equation is X minus H squared plus Y minus K squared equals R squared. So for this one, when we plug in our values, we're going to get X minus 0 squared plus Y minus 0 squared equals 8 squared. For both of these, we could simplify it by getting rid of these zeros and just saying X squared plus y squared equals, and then we square our 8, which is going to give me 64. And this is something that we're going to see a lot. When you see x squared plus y squared in a circle equation, you could, when you see this, it should immediately tell you, hey, this is at the center. This is at the origin. Our center is the origin. So our circle, if you think of our coordinate plane, that looks something like this. The center of the circle is going to be this point right here, right at our origin. So this circle is going to look something like this, where this is at 8, 0, right? Up here is 0, 8. That's what this circle looks like. Something like that, right? The center of the circle is right at the center of our coordinate plane, aka the origin. Cool. Let's keep it cruising. The next one, now we have different values. We're going to have to plug them in, and we want to write the equation of the circle. So once again, what is the equation of the circle? It is x minus h squared plus y minus k squared equals r squared. And we want to plug everything in. We know that h is here, k is there, and this is my r. Let's substitute everything in, and we get x minus 3 squared plus y minus negative 5 squared equals 6 squared. When we have something like this, x minus 3 squared, we can't do anything to simplify this, right? We're going to leave it just like that. So we write it as x minus 3 squared plus. But this is where we can simplify, because when we have a minus and a negative number, we could simplify that and make it y plus 5 squared. And there we go. That's the simplest form we're going to have on the left side of this equation. Equals, and all we want to do is square our 6, which is going to give me 36. And there we go. We got our answer. So we get x minus 3 squared plus y minus 5, or y plus 5 squared equals 36. And there we go. This is the equation of a circle that is centered at 3, negative 5 and has a radius of 6. Now, we want to do this, but we're not told the center or the radius explicitly, right? We can figure it out from this picture, though, right? We have a picture of a circle, and here we go. We got the center of P, and we could count the radius because it's on a grid. So let's first figure out where our center is at. So if this is my origin, the center is located at 1, 2, 3, 4, 5 units to the left, which is going to give me a negative 5. We could say that this is at negative 5, comma, and it doesn't move up and down, so 0. So the center is negative 5, comma, 0. And now we need to figure out my radius, and we could just calculate the radius. Or by calculate, I mean count. So we could just count the radius. It goes from their center, 1, 2, 3, 4, 5. So the radius is 5. Oh, I'm having a hard time drawing my 5s today. 5 units. And with this information, we can now plug everything in. Let's first label it, though. We got H, K, and here we have our R. So let's write our formula. Remember, it is X minus H. And I suggest you write this out every single time. 1, it will stop you from causing errors, right? And 2, it's going to help it stick into your brain, right? The more you write this, the easier it is to remember. So we get x minus h squared plus y minus k squared equals r squared. So let's plug in my h, my k, my r. So once again, we get x minus, what's h? Negative 5 squared plus, whoops, forgot a parenthesis, y minus 0 squared equals 5 squared. And let's do our simplification step. So now let's simplify. So for my first parentheses, we could simplify here because we have minus and negative. We get x minus, or just kidding, plus, because we have the minus negative, 5 squared, plus, and when we're subtracting a 0, we get rid of it just to get with y squared, equals 5 squared, aka 5 times 5 is just going to give me 25. And there we go. We got our equation of our circle. So let's box it off. And now we're good to go. So this is the equation of the circle in our picture here. It is 5, 0, our center. And when we look at this, we should start trying to figure out, hey, what's going on? The way we could get ideas from this equation is we could tell our center and we could tell our radius. Our center is going to be whatever is next to these x's and y's. So next to this x is a plus 5. When we're in parentheses like this in our equation, we have to think opposite. So instead of a plus 5, we're thinking negative 5. There's my negative 5. And next to this is nothing, aka 0. So negative 5, 0. There's my x and y coordinates. And then you just have to figure out, hey, what's the square root of the number on this side of the equal sign? Square root of 25 is 5, which is this distance right here, also known as the radius. It is 5. And that's how these things connect. So let's keep it cruising. So next up, we have an example problem here. It says the point negative 5, 6 is on a circle with the center negative 1, 3. And it asks us to write the standard equation of the circle. Now, this one's a little more difficult because we don't have our radius. So you first need to find the radius using the distance formula, right? And that's what they do here. It says to write the standard equation, you need to know the value of h and k and r. To find r, find the distance between the center and the point negative 5, 6 on the circle. So we set it up with our distance formula, right? We plug in our values, negative 5 minus negative 1 plus 6 minus 3, which is going to give me a negative 4 squared plus a 3 squared. We square them and simplify, and we get our answer to be 5. So our radius will be 5 in this example. And we already know our center, which is my h and my k. So we have hk equals negative 1, 3, and my r equals 5. You plug everything into your standard equation right here. And this is exactly, these steps right here are what we did on the other side. It just took a second to get to those steps. So you plug in your values, and then you simplify, and you get your standard equation right here. So take a second, actually look through this, and make the connections in your own head of what they had to do here. All right, so on our next slide, we have a question that is actually coming from a state test, right? So it says in XY coordinate plane shown, points B, E, G, and I are on circles with the center H, right? So H is our main circle, but all these points on that circle also have circles, right? They're trying to confuse you in this picture, but all we want to do is focus on this circle H here. And it says, what is the equation for circle H with the center H, right? So first, let's find the coordinates for this. So the coordinates for H is down 4 and 2. So it's at 4, 2. Now remember, whatever our center is, the signs should be opposite in our equation. So negative 4, negative 2. So that counts out these bottom two right here. Now all we have to do is figure out how many units is our radius here. So let's start at our center and let's start counting out. It goes 1, 2, 3, and a little over 3. So does this 10 make sense? No. Actually, yes, it does. Sorry about that, because this is our radius squared here. So if it's simplified, we don't want to do our radius squared and it be the square root of 10, because if you square the square root of 10, that means it's 10 units. But we want to take the square root of 10 still. So our answer here is B, and A is out of the running. Because we have to take the square root of this 10, and the square root of this 10 is going to be 3 point something, which is exactly what we have going on here, because it's 1, 2, 3. But notice it's past that line of 3, so it's 3 point something. That's exactly what we want. So there we go. We got our our center right there. Next up, it says the equation x squared plus y squared minus 6x plus 2y plus 5 equals 0 represents the circle with which center? Now, we're going to come back to this one because we're going to learn how to solve this in a moment. And then we'll come back and we'll get this answer. So let's look at this one though. It says the circle P is graphed in the coordinate plane with the center 2, 3, and P contains the point 4, 6. What is the equation of circle P? So we could already do our center because it says HK here. So this is HK. So we could plug these into these spaces here. So in our first space, it's going to be H, which is just 2. In our second space, it's going to be our K, which is 3. But we don't know our radius here. We don't know our radius. So we want to be able to solve that in. And this is where we have to use our distance formula. So instead of putting D, we're going to put our R because our distance formula is going to give us R. And it's the square root of x2 minus x1. Oh, not x2 up there. It should be x2 down here. Minus x1 squared plus y2 minus y1. So x2 is 4. So we're going to go R equals the square root of 4 minus 2, right here, x1, squared plus y2, 6 minus 3 squared. So once again, we slowly simplify. This is going to be a square root. 4 minus 2 is 2 squared plus 3 squared. Next up, square those. And we get the square root of 4 plus 9. That's going to give me square root of 13. And this is what we're going to have to simplify. Go to our calculator, do square root of 13, and that's going to give me about, our final answer, R, is about 3.6. So our answer right here isn't just going to be 3. Actually, sorry, we're going to leave it like this. Square root of 13. Because when we square it here, to get our radius for the equation here, 13, we square root of 13 squared is going to give me 13 even, which we'll plug in right here. And there we go. We got our answers. Let's keep it cruising. Next up, another question. It says circle Q, defined by the equation x squared plus y squared equals 16, is graphed in the same coordinate plane as circle P. Select from the drop-down menus to correctly complete each statement. So it says the center of circle Q is either above or below, to the left or right of circle P. Let's reread what we got up top. We have these equations, right? And this goes back to the same thing that we have here. We know the center of our, wrong way. So the center of circle P is at 2, 3. So let's write that over here. So we have it written on this slide. P is at 2, 3. Q, where's the center of circle Q? Well, do we have anything next to my X? No. Do we have anything next to my Y? No. So Q is at our origin, 0, 0. Now we can use this information. And it says the center of circle Q is going to be either above or below. Well, 0 is less than 2. So that's going to be below. And then 3, or 0 is less than 3. So that's going to be to the left. So it's below and to the left of circle P. And now next up, we want to know the radius. Well, the radius here is going to be the square root of 16. So for circle Q, the radius equals the square root of 16, which is just 4. And then circle P, the radius, if I remember correctly, is the square root of 13. And the square root of 13, we said earlier, is about 3.6. So which one has the bigger radius? It says here, the radius of circle Q is bigger, so greater than the radius of circle P. Awesome. We broke it down. We kept it cruising. All right, so next up, we have to review something called completing the square. And we're going to need to use this in order to determine the center of the circle. So we learned about completing the square in our past algebra classes, or at least we should have. And today we're going to go over it again. This side says, by expanding the binomial terms of a standard form of a circle, x minus h squared plus y minus k squared equals r squared, the equation could be written as this following. X squared minus 2hx plus h squared plus y squared minus 2ky plus k squared equals r squared, right? Or you could separate it differently and put x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared. That's just moving things around, right? And the equation for the circle in the general form is ax squared plus cx y squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are constants, right? So this is just, a quick overview of that. And it's probably super confusing with all these letters. So let's actually get into a problem and see how this works and do a little bit of a review so we understand what we're doing here. But to identify the center and the radius of a circle written in general form, you need to rewrite the equation in standard form. It is often necessary to use completing the square to rewrite the equation in standard form. And that's what we're going to have to do right now. So here we have an example, right? And in this example, it gives us our general form equation right at the top in black here. This is x squared plus y squared minus 4x minus 6y plus 8, right? That's not the form we know. We can't tell the center or the radius from this, but we want to get it into that form. The first thing you have to do is move your constant. So we move the constant. And how did they do that? Well, they subtracted 8 from both sides, right? They canceled here, and it gave me negative 8 on the right side of the equation. Next up, they created these little spaces here, right? Which you could just do all in one step here in future purposes. And what they had to do was find the numbers to put in these boxes. The way they did that was they took this number here, which we're going to call b, and you divide it by 2 and then square it. So let's see a little example here. We have negative 4. Actually, we could just take the number. It doesn't matter if it's negative or positive. Let's say 4 divided by 2 is going to give me 2. But we want to square that, which will then be 4, which we put in that blue box. Let's do the same thing for my red one, 6, right? We have 6 divided by 2, which will give me 3. But then we square it, which will give me that 9, which is in that red box. And that's how they got those numbers, right? And what you have to do is add them to both sides. This is the completing the square. So we're actually doing it twice for my blue equation and for my red equation here. We're adding both of those to the equation, so we have to add them to both sides. So we added it here, here, and then we added both of them on the other side to that 8. And finally, all we do is simplify. So you factor. The way we factor is whatever you do, whenever you divide this by 2, that's what goes in here. So we get x minus 2 squared. Divide that 6 by 2, it gave me that 3. So we get y minus 3 squared. And then we get equals, and we do negative 8 plus 4 plus 9, which will give me 5. Now, this is an equation that was already done, and it still might be a little confusing. So let's do it ourselves. And here's the equation we want to rewrite, right? So I'm going to rewrite this thing exactly how it is right here. So we get 2x squared plus 2y squared minus x plus 4y plus 2. And that's going to give me 0. The very first thing we want to do here, since we have a 2 in front of my x and my y here, we want to factor that out, right? So what we're going to do is divide everything by 2 here. And what we could kind of do is we could kind of get rid of it. Because if we divide everything on this side by 2, then divide my 0 by 2, it really just disappears over here. So let's do that. So we get this divided by 2 is just going to give me x squared plus y squared minus 1/2 x plus 2y plus 1. Now, the very first step that we have to do here, equals 0, is we have to get this constant over. So we're going to subtract 1 on both sides. And we can rewrite this, right? But when I rewrite this, I also want to reorganize. So we're going to get my x's. We're going to get x squared minus 1/2 x, because that has the value x, and then we're going to leave a gap. And here we're going to do plus y squared plus my 2y, and then we're going to leave a gap. This 1 disappears because it's bringing it over here, equals -1. So we need our two different b's here, right? So we're going to say one is my green, and then the other one is going to be my purple. So b is that number in front of our x and our y variables. So the b here is 1/2. If it's negative, we're just going to take the 1/2, right? So we're going to say 1/2. So we're going to do 1/2, and we want to divide that by 2. So what's that going to give me? That's going to give me 1/4. Now we want to square 1/4. Right? So we square this. And what is that going to give me? Well, if you're having trouble, you could always go to your calculator and you do 1/4 squared. And that's going to give me 1/16. So we're adding 1/16 here. So it looks silly, but our green one is going to be, equals 1/16. Oh, we're going to do plus 1/16. And now we need to do our purple side. So we start with 2 or -2, right? But we'll see why it's not going to matter. We divide it by 2, which will give me, because we want the opposite. That's why we took the -2. Sorry, I didn't explain myself. We have a plus 2 here. We take the opposite, which is -2. We divide, which will give me a -1. But we need to square that. And when we square a negative, it turns out to be a positive, which is just going to be 1. So we add a 1 here. But we need to add the green and the purple to my other side. We forgot to do it. We didn't keep the seesaw even. We have to do plus 1/16 and a plus 1. So finally, we can now figure all this out, right? So we factor our left side, and that's going to give me, I'm going to do them in different colors to keep them organized. It's going to give me x. We take whatever sign's in the middle here, minus. And then we do this value that's in here. So it's going to be a 1/4 squared. Plus, let me switch to purple. We get y. And here, instead of a minus, we're going to have a plus 1. This is the value in here, but the opposite, right? Squared. Equals, switch to red. Equals, and then we add all this up. The -1 and the +1 cancel, so we're left with just 1/16. And there is our equation of the circle in standard form. A lot of work. It could be a little complicated, but if you're stuck, rewatch this over and you could get it, right? And ask for help. Let's see it again. Now this one's going to be actually a little easier. So the last one was a little more complicated. This one already written in a form that we like, so we just have to reorganize and then solve it. So let's start there. So our reorganization step, let's do it. We get x squared. Where's my other x? It's right here, -2x. Do minus 2x. Leave our gap to fill in. Plus y squared. Where's my other y? It's a plus 4y. Plus 4y. But we need to get this 4 over. We subtract 4 on both sides. We leave our gap here and we get equals a -4. So that's our reorganization step. Now we need to fill in these gaps. Once again, I'm going to assign colors to kind of organize things. My x's will be green. And my y's will be purple again. first, let's figure out what we need to put in my x side. So the number next to this x here, aka that b number, is -2. The first thing we want to do is divide it by 2. It's always going to be a 2 that we're dividing by here. That's going to give me a -1. Sorry, this isn't going to be negative because you just want to take the opposite. So it'll be 2, that'll be 1, right? And then we want to square it, which is just going to give me 1. The number we're putting in here is a +1. And we're always adding numbers here. That's one thing I want you guys to notice. When we complete the square, it's always going to be an addition of a number, never a subtraction. Next up, we got our purple. And since it's positive here, we take the opposite once again. So -4. Divided by 2, which will give me a -2. When we square that, -2 squared is really going to be 4. So we're adding 4 to this side. But once again, we cannot forget to add these numbers on the other side. We say +1 and +4. So on this side, the 4's cancel, -4 and the +4 cancel, and we're left with 1. But on our other side, we have to factor. So let's factor. Let me switch my colors. For the x's, we're going to get x minus, what's the number here? Or going to be a 2. We get x minus 2 squared plus y. And since it's a plus here, we'll put a plus here. And it's going to be a 4. Actually, it's going to be 2. Sorry. It's after the division. So it's going to be 2. I messed this up. Rewind. This should be a -1 because it should be the number that we're squaring here. And this should be a 2. Forgot to switch my color though. Wow, I'm really off. I apologize, guys. Reverse, right? So we put a 1 in here because it's the number after we divide by 2. And then on this side, we get y. And then we get a +2 squared. Equals, when we simplify this side, it will be 1. There we go. We got our equation. Nice and easy. Beautiful. So now we get our state testing one, right? And this one, all it says is an equation of a circle and an xy coordinate plane is represented by the following. What is the x coordinate of this equation? So we have to rewrite it in the form that we know, and then we have to find out what the x coordinate is. So let's do that. So this one, a little simpler here. So what we could put is, let's rewrite. We get x squared. We have one more x, so -6x. Leave the space, plus y squared. We don't have a y here. So this y is done. We don't even have to factor this or complete the square on it. And then our 11's already on the other side. So we just need to figure out what is the b here that we want to add here. So we get 6, we divide it by 2. That's going to give me a 3. We want to square that, which will equal 9. So this is the number we're adding. We do +9 on both sides. So then we just need a factor on my left side. So what's the half here? It's a 3. We got a minus sign here, so that's going to be minus. So we're going to x minus 3 squared plus y squared equals 20. There's our equation. So what is my x coordinate? Well, it's going to be the opposite. Since this is minus, we take the opposite, and my answer is going to be a +3. There we go. And next one. It says here we want to fill in this little thing down below. Basically, all we're doing is filling in this distance here, right? In other words, it's asking us what is our equation for the circle. So we get x minus h and then y minus a. It's just trying to design the equation of the circle here. So you'll drag and drop your x, h, y, and k using this idea right here. Next up, because triangle ABC is the equation of a circle, using Simon's Pythagorean theorem, they want us to write this equation of the circle. So just using the variables here, we want to write it all we're doing is writing the equation of a circle. It makes it a lot more complicated here. But if you've been doing it for every single problem, this one should be super easy, because all it is x minus h, y minus a equals r squared. There we go. We just plug everything in that we knew. And there we go. We finished our PowerPoint. We learned about the equation of the circle. I wish you guys luck. If you need help, let me know. Let your teacher know. Or comment down below if you need extra help. Thank you for learning today. Hope you guys have a great rest of your day. Peace out, everybody.